For the last few days, we've been reviewing how to add numbers using expanded notation and add by place. Today, we're going to get practice on how to use what we've learned to add 3 or more numbers, or multiple add-ins. We remember that add-ins are just the numbers that we put together or that we add in an addition problem. Let's read the problem together. Mrs. Lee wants to know how many families went to the city basketball tournament championship game last Wednesday. There were 231 families from East New York, 349 families from Bushwick Elementary, and 143 families from Apollo. How many total families attended the championship game? Go ahead and take a look back at your work. How did you represent this problem? Go ahead and say your answer out loud and be sure to explain why it matches the story. I heard many friends say they represented with an equation that looks like this. Why does an equation like this match the story? Say it out loud. Yes, that's right. 231 represents the families from East New York, 349 represents the families from Bushwick Elementary, and 143 represents the families from Apollo. If we put together all the families that attended from each school, we will get the total families that attended the game. If you made a mistake with your representation, go ahead and take a moment right now to fix it before we get into our solving steps. Great job. Now let's move on to how you solved. I know that we've been practicing strategies like add by place and expanded notation. How did you solve this problem? I heard some friends say that they solved like this. Let's take a look at this student's work. What did they do to solve our addition problem with 3 add-ins? Say it out loud. Yes, that's right. They added 231 to 349 to represent East New York and Bushwick Elementary. And then they added that total to 143 to represent the families from Apollo. Okay, let's take a look at their addition. What addition strategies did they use? Say it out loud. Yes, that's right. They used add by place. What steps did they take to add their first 2 numbers? Go ahead and say it out loud. That's right. First they added 1 and 9 to get 10 ones. Then they added 30 and 40 in the tens place to get 70 in the tens place. Then they added 200 plus 300 to get 500 in the hundreds place. Then they added the sums of each place value together to get a total of 580. Was 580 the answer to our problem? Evaluate. No, it was not, because this student only added 2 numbers first and then added the 3rd number. What did they do next? What steps did they take to add our total from the first addition to our number of families from Apollo? Go ahead and say it out loud. That's right. This friend added first in the ones place, 0 plus 1, to have 3 in the ones place. Then they added 80 plus 40 to have 120 in the tens place. And then they added 500 plus 100 to have 600 in the hundreds place. Then they added up the sums of each place value to get a total of 723 families. Interesting. So this friend chose to add two numbers at a time and then go back and add the third number. Interesting. They chunked their addition up. That kind of reminds me of a strategy that we use and that we learned in second grade to add many single-digit numbers together. They also chose to use add by place. Team, do you think this is the only way we could have added our numbers together to find the total? Evaluate. I see lots of friends shaking their head no, so let's take a look at another piece of student work. I heard some friends say that they solved using expanded notation and it looked like this. How is the way that this friend solved different? Go ahead and say your answer out loud. Yes, that's exactly right. This friend used expanded notation and they chose to add all three numbers at the same time. Interesting. Let's take a closer look at their calculations. How did they use expanded notation or expanded form to add all three numbers together at the same time? Go ahead and say it out loud. That's right. This friend added in the ones place first. 1 and 9 is 10. 10 and 3 is 13. They recognize that we can't have 13 in the ones place, we can only have ones. So they regrouped 10 ones to the tens place. They had 3 ones left. What did they do next? That's right. They added 10 plus 30, which is 40. Then they added 40 plus 40, which is 80. Then they added another 40, which gave them 120. What did the student do when they noticed that we had 120 in the tens place? Say it out loud. Yes, that's right. They knew that we couldn't have 120 in the tens place, so they regrouped 100 to the hundreds place, and we had 20 left. Then they added in the hundreds place. 100 and 200 is? Yes, 300. 300 plus 300 is? Yes, 600. 600 plus 100 is 700. For a total of 723 families. So both scholars worked very differently. Did they get the same answer? Evaluate. Yes, they did. Remind me again, what did these two friends do differently to solve? Go ahead and say it out loud. Yes, that's right. This friend chose to add 2 numbers at a time and then add the third number to their total. They also chose to use add by place. This friend chose to add all three numbers at the same time, and they used expanded notation. That makes me think that there's many different ways that we can add numbers when we have multiple add-ins. When you're adding more than two add-ins together, you can think, what strategy can I use to add? Choosing between expanded form, add by place, or another strategy that makes sense to you. And you can think, do I want to add two add-ins at a time? Or do I want to add all add-ins together at the same time? Keep this in mind as you jump into the try one more.